Welcome to the first video of the week. Here's the essential question. I'm going to try my best to always put the essential question in the first slide. How do we determine the slope of a line given 2 points? So how do we determine? That is what we're going to do. Where's my pen? There it is. Determine what? Of 2 points. Let's keep on moving. Make sure you're positive if you still need to write this down. Talking about this, I'm going to go a little bit fast in this because most of you already saw this stuff in Perez's class. If not, you saw it last year in Algebra 1, so this for the most part should be review. Now in words, I'm always going to give you the words, the algebra, and a visual representation. So in words, what does a slope mean? A slope, m, I'm always going to write m, of a non-vertical line. We're going to get to why it has to be non-vertical, is the ratio of a vertical change, the rise to the horizontal change. So it's pretty much what it's asking for, it's a rise over 1. So if you have 2 points, x1 and y1, also shown over here, x2 and y2, also shown over here, the slope is pretty much what you do to get from this point to this point. So if you see from this graph, you're going up some amount of steps, and then you're going to the side an amount of steps. And the way to figure this out is if you do your x2, y2, so you have y2 minus y1 divided by x2 minus x1. These two are from 1 point, these two are from the second point. It doesn't matter, the order doesn't matter, just stay consistent. Just make sure that the ones on this side are from 1 point and the ones from this side are from the other point. And again, this is all just rise over 1. And let me put actually a square around this because this is going to be the most important part of this entire week. So make sure you write that down, bold, highlight it, color it, make it fun. Alright, so in this example, we have 2 points. The question is, find the slope that goes through 4, 2 and negative 3, 16, where x is measured in hours. Let me underline that. And y is measured in dollars. So this is very similar to what you're used to seeing, except this time you have units. X is in hours and y is in dollars. And we're going to go through how to deal with questions like that. So if you remember from the slide before, the general equation is y2 minus y1 over x2 minus x1, because we want to see the change in the height, or the change in the vertical, and the change in the horizontal. This is equal to, let me write down the skeleton, and change these colors. So if I say this is x1, this is y1, and this is x1, and this is y2, all I have to do is plug those in. Y2 would be 16, y1 would be 2, x2, sorry I wrote that wrong, would be negative 3, and x1 would be 4. Now let's do the math down here. What's 16 minus 2? Well, that's 14. What's negative 3 minus 4? Negative 7. What's 14 divided by negative 7? Negative 2. That looks like our answer, but we're not done. Don't forget about the units. We always have the units. You're going to be using units in this class and with Ms. Malzahn in chemistry. Here's how you deal with the units. Let me write the units in a different color. So, if you're talking about the units for the y, remember y is measured in dollars, so I usually just write the little money sign up there, the little divided sign. What's the x? X is in hours. So the dollars is on top, the hours is on the bottom. Another way, let me write this down over here. Another way to write that is negative $2 per hour. And that's actually your final answer. Remember this, it's dollars per hour because you're looking at the rate of change. So you're looking at how much for every y that goes up, how many x's go to the side. So for every dollar you get, or for every hour you go in the x-axis, you gain $1. So it's negative $2 per hour. So in this case, it actually means you're losing money. So remember, when you have units, all you have to do is say y per x, dollars per hours.